All right, today we're going to talk about what's called the common logarithm. So first thing we're going to do is evaluate logarithmic expressions using the change of base formula. We kind of talked about that already, but we'll do a quick review of it. And then we're going to solve exponential equations and inequalities using common logs. And obviously, like I said, your calculator. So change of base is when we have log base 3 of 11. We can do log of 11 divided by log of 3. We covered this a day or so ago. Now, notice here it just says log and there's missing a base. The log base 10 is what's called the common log. It's used very often. It's used more often than any other one except for the natural log, which is tomorrow's assignment. So since it's used all the time, we don't tend to write the base very often, the 10 there, because it is used that often. So we go ahead and just drop it, and it just log of 6. And so there's no base here. And so when you type this in the calculator, you can just hit log of 6. You do not have to do log of 6 divided by log of 10. You can if you want to, but you don't need to because it's already given that it's base 10. So you're just typing log 6, enter into your calculator, and we get this long decimal point. And again, we round to the nearest 10,000th, so 4 decimal points, so 0.7782 should be what we have here. Yep. And we can do it with the log of 0.35, and you enter it and you get negative 0.4559, so 4559. Now when we have log base 5 of 140, then we can do log 140 divided by log of 5. So we're going to do the 1 divided by the second, and you type that in and you get 3.0704. So this one's log 16 divided by log of 5. That gives us the 1.7227. Those are all things that we've done already. It should just be review. So the new part is how to solve exponential equations when they're not the same base. Earlier on in the chapter, we went ahead and simplified ones that had the same base, and then the bases canceled out and we were able to solve it. We can't do that with all of them because they're not all going to have the exact same base. So in order to solve that, we need to take the log of both sides, and then we move the exponentials to the front of the logarithm, and then we solve for x. Remember, a log of a number is just a numerical value. You can just type it into your calculator and you can get a value for it. Sure, it's a decimal most of the time, but it is a decimal that we can go ahead and just move and manipulate, add to both sides, or subtract or divide or whatever it is we need to do. So let me show you how we do this. So we have solve 5 to the x equals 62. Now notice these two do not have anything in common. I can't birthday cake 62 and get down to a 5. And the ones earlier in this chapter, we would be able to do that. So what we end up doing is we end up taking the log of both sides. So I go ahead and I do the log of 5x, 5 to the x, and log of 62. Now remember, an exponent can also come out in front in terms of using the property of logarithms to go in front of the log. So that x comes in front. There's no exponent here, so I don't need to bring that in front. So I have x log 5 equaling log 62. Now these are both just numbers. You can type them into your calculator. If I do log 62, I'm going to get 1.79, and I could do log of 5, and I can get 0.6989. And those are just numbers. So even though it's a weird looking log of 5, I can just divide by the log of 5. So I'm going to do log of 62 divided by log of 5 in my calculator, and I get 2.5643. And that's my answer. Let's try another one. Obviously, we should always check our answer, but let's try another one. Here we have x plus 4 in the exponential. So we take the log of both sides. So log of 3 and log of 17. And that x plus 4 now goes to the front. Now this is in parentheses. You'll want to have it in parentheses so I can distribute the log 3. So it's x log 3 and 4 log 3. I just use parentheses to help you see where we're at. And of course, this is still just log 17. Well, 4 log 3 has no value in terms of an x. So I need to go ahead and move it over. It's just like having 2x plus 4. I would move the 4 over. All right, because it's 4 log 3, who cares? So I move it over, and it's a minus 4 log 3. I have a number in front of the x or with the x, so I divide by the log of 3. So log 17 is 1.230. 4 log of 3 is 0.4771 times 4. And then we're going to divide it by the log of 3. Type that all in, and we get negative 1.422. I don't know what happened. That should be probably a 0 there at the end. Something happened. We lost a decimal point in there. So what if there's exponentials on both sides? Well, it makes it a little more difficult, but we can still solve it. So here's the original. Now we're going to take the log of both sides, and then these are going to go to the front. The exponentials are going to go to the front. So 7x log of 3 and 5x minus 3 log of 2. We're going to distribute the log of 2. Over here, we don't have to distribute at all because it's already just all one thing. There's no pluses or minuses, no other terms. So I distribute the log 2, so they both get a log 2. Now this has an x and this has an x. They need to get together. So I got to move one of them over. So when I move it over, I make minus 5x log 2. Because it's positive over here, I got to move it over. Now what I'm going to end up doing here is I'm going to factor out an x. I'm going to take an x out of both of these. So I'm going to have x log 3, 7 log 3, and 5 log 2 left after I take the x out. Now notice it's x times. So how do I get rid of it? I have to divide. So I'm going to divide both sides by that amount, and then that's just something we type into our calculator. I would highly recommend doing the numerator first, writing the answer down, then doing the denominator, writing that answer down, and then doing the dividing. Otherwise, you have to put in a lot of different parentheses here, and it becomes very difficult. They went ahead and just put in the different, what log 2 is and what log 3 is, but eventually you get x is greater than negative 0.4922. Again, you should go ahead and test the points. They're trying 0 because it is greater than. And so when they try 0, 3 to the 0 is 1, 2 to the negative 3 is 1/8, and 1 is greater than 1/8. So we've done the right thing. So what about this one? By taking the log of both sides, the 3x is going to come in front, and the x minus 2 will. Again, we distribute the log 10. So x log 10 and negative 2 log 10. This is an x that needs to get moved over to the other side, so it's x minus the other x. Then I factor the x's out, and it's 3 log 5 minus log 10. I'm going to have to divide by that amount. So negative 2 log 10 is just negative 2. Putting this into the calculator, it's 1.0969. Dividing it, I get negative 1.8233. So you're going to rely a lot on your calculator here to do these different parts. But notice how I did this again. I did this and wrote it down, and it's just negative 2. And I did this and wrote it down here, and then I wrote the division in my calculator. It just makes it a lot easier. You can type it all in, but it can be very confusing with all the parentheses that you will need to have in there. So I highly recommend numerator, denominator, and then divide them. And that's what I have for you today.